Hey guys, so here we're going to review the last 4 questions on the final exam review sheet. So these questions are on the review sheet. It's question 6, 7, 8, and 9. So we'll start right with question number 6. Question number 6 is talking about infant mortality rate. Deaths during the first year of life. This is sad. Okay. Generally, the infant mortality rate provides the number of deaths per 1,000 living births. Okay. So here's a study that listed 24 nations and the rate of deaths. So we can see here that we have the different nations or different countries and the rate here. Okay, so this data is given to us. I actually already put this in Minitab because right away it says draw a box plot. That means I have to get the 5-number summary. I'm going to calculate the fences, all of that stuff. So I have to go ahead and put this into Minitab and get my mean, standard deviation, my 5-number summary, all that stuff. So I actually already did that. So I'm going to share my screen so you can see my Minitab here. Okay, so here my Minitab, you can see in column 4, I'll just expand this a little bit. You can see here in column 4, I have the mortality rates just listed in one column. So that's the column we will use. So what we want to do first on this problem is we want to go to Stat, Basic, Display Descriptive Statistics. Now, the default for this will give me the 5-number summary, it'll give me the mean, standard deviation, just all those basics. So I don't really have to ask for anything extra, but I can. So here I want to put column 4 in my variable. And if I wanted to change my output, I can go to Statistics, and I can select or deselect any of these to get what I want. All right, so I'm just going to select OK. I'm not going to do anything fancy, just get what it gives me. So here's my output. So here's my variable, n is 24. My mean, so x bar is 7.8. Standard deviation is 1.36. Then I have my 5-number summary: minimum, quartile 1, median, quartile 3, max. Okay, so it says to draw a box plot and make sure to label and show any outliers. So what I need to do here is I need to calculate my lower fence and my upper fence. So here I'm just going to start with the 5-number summary, even though it doesn't quite ask me to say what the 5-number summary is. Remember, the box plot is a graph of that 5-number summary. So I'm just going to include these values. So 4.59, 7.2. Sorry, I think I have a discrepancy between my page at home and what I'm getting here. I did not double check my numbers, which I should always do. I think I said that in the last video. You should double check your values that you plug into a column, and then you don't have to worry. Okay, that one's cutting it close. There we go. And then I'm going to get my lower fence and upper fence. So before I leave the Minitab screen here, I'm going to just take a look at what the box plot looks like, and then I'm going to draw it by hand to make sure it looks the same. So box plot under graph, simple, column 4. Now here I'm going to go to data view and ask for that mean symbol, because this helps me determine my shape, gives me a really good idea. My scale, I'm going to just turn it so it's sideways instead of up and down. That is a preference. You do not have to do that. All right, so I'm going to click OK twice. I'm going to get a little visual here. Okay, there it is. So looks like there's an outlier on the left. So let's keep moving forward here. Maybe I'll double check my values really quick. Sorry, I was trying to avoid taking this time, but I was just concerned. that my numbers off a little. Okay, these numbers look good, so maybe I just wrote something down wrong before on my other page. So I'm going to stop sharing this and we can just go right to the paper here. So the first thing we want to do is we need to calculate the IQR. Not that it asks me for this, but when I calculate those fences for the cutoff values, then I need to calculate this. So quartile 3 is 8.59 minus 7.24, which is my quartile 1. Okay, so when I do that, I should get 1.35. Okay, and I'm going to multiply that times 1.5, and what that will do is give me the value I'm going to add or subtract to get my fences. Okay, so I'm going to just hang on to that number. It's just a little over 2, but I'm going to hang on to that number. So for my lower fence, let's talk about how I calculate my lower fence. My lower fence is quartile 1 minus 1.5 times IQR. Okay, so quartile 1 is 7.24 minus, now I took this IQR, multiplied it by 1.5. I just got a little over 2. I'm going to include, I'm not going to say 2, but it's 2.025. Okay. And then what I'm going to do is I'm going to take my IQR 1 and subtract out that 2.025 to get 5.215. Okay. Then I have my upper fence, which is quartile 3 plus 1.5 times IQR. So quartile 3 is 8.59 plus that 2.025. Okay, so I'm going to take 8.59. I'm going to add 2.025 to it, and I'm going to find, oops, that's an equals, is 10.615. All right, so those are my cutoff values. So any value greater than the 10.615 will be considered an outlier or an unusual value, and any value under the 5.215 would also be considered an outlier or unusual value. So let's start drawing the box plot. Now, typically, if I give you a box plot, I give you a scale. You know, on, I believe this would have been on test 1, would have given you like a scale. And I try to stick with that, and everyone's kind of looks the same. So anyways, here we can see the max value is 10.19. So I don't have to go that far above 10, and the lowest is 4.59. So I don't have to go that far below 4. So I'm going to start at 0 just because I like that. And I will probably run out of room because I feel like I'm making these numbers too large. I got to start over. I'm sorry. My scale will not be right. All right, let's try that again. Get these a little bit closer. And it's not super consistent, but we'll get the idea. Okay, so there's my scale 1 through 10, or 0 through 10. I don't really have to do it like that, but I will. Okay, so my lower fence here, I'm just going to use a pen. So my lower fence, 5.215. So 5.215. So somewhere's up in here will be my lower fence. My upper fence is 10.6. So that's up here, kind of like right at the edge of the paper. Okay, now I'm going to go ahead and put my 3 middle numbers in, Q1, Q2, Q3. So 7.24, so somewhere's around here, 7.6, so right around here, and then 8.59, somewhere's around here. Hanging on the right thing. Wow. Okay. All right. So this is where I'm looking for my box plot here. Now, I did get a mean, and I don't think don't think I wrote it down, but I think it's 7.8. So I'm just gonna look real quick before I move forward. So I'm gonna put that on there. Yeah, 7.823. So just going to say X bar equals 7.823. So I'm just having that as a little side note because my median is 7.6. So this is just a little bit to the right around there. Not perfect, but we get the idea. 10.19 is my largest value. It's inside my fence. So that's going to be where my whisker ends here on the right. Then on the low side, 4.59 is my smallest value. So 4.59 is below my lower fence, right? It's down here. So if 4.59 is down here, then that means it is an outlier. It's not where my whisker, like I will not draw my line past that fence. Remember, I only draw my whisker inside the fence to the next value. So that's inside the fence. So I'm going to take a look. And when we look at the paper, the data was given to us. Sorry, this is very, not very good quality of, of a picture here, but 4.59 and 5.77, like they're in order. So 5.77 is the next smallest, and that's inside the fence, right? 5.77 is somewhere around here, and that's where my whisker will end. So not the greatest box plot, but we get the idea. I apologize for that. So anyway, so I have my fences, it's like that I calculated, my mean, and I have my outlier showing, which I thought, right, because we saw that on Minitab and my box. All right, so it says, let's see, I'm just going to read through this. All right, so what is the typical value? So it's got a couple questions here to go along with this. So one, it says, what is the typical value for mortality rates in the box plot? So remember, typical values center, and when we're on a box plot, what we're looking at is the median, not the mean. So my median here is 7.64. So that's my typical value, is my median, okay, for center. Then on the second one, what is the spread? Now remember, the spread is IQR. So we already calculated IQR and put it up here. It's at 1.35. So I'm going to go ahead and write that. That is the typical spread here. All right. And then number 3, what is the shape? Now, remember, the shape is kind of your own interpretation, right? Sometimes they're a little iffy, like if they're symmetric or if they're skewed left, skewed right. You know, one person might say skewed right, and the other one might say it's more symmetric. This one is a little tricky. So when I'm looking here, my whiskers do appear to be about the same length, right? But my mean is larger than my median. Okay, the mean is 7.8 and then the median is 7.6. So typically, if we said the mean is greater than the median, then we would indicate that it's skewed to the right. Okay, but if I didn't really look at that, then it makes me a little, you know, looks a little symmetric. Although my median is further to the left in my box than to the right, which makes me think maybe it is skewed right. So I'm going to say skewed right. If you said symmetric, I wouldn't completely disagree with you. I feel like it's one of those things that could be a little on the line. But if you said skewed right because the mean is greater than median, I would 100% agree with that. All right, and then number 4, are there any outliers? Yes, of course, we already addressed that. It's the 4.59, that low value. Okay. And that's it for question number 6. All right, let's move on to question number 7. So question number 7 always has a bigger data set. That's all right. All right, question number 7, we're looking at, so it has a data set of 64 of known offenders for auto theft, okay, in Garden City, Michigan. So we have a table here and it has 64 values here. So what I did was I went ahead and put this into Minitab so I can move forward with the problem. So here it says compute the following values for the sample. So mean, standard deviation, 5 number summary again, box plot. Oh, it's another box plot problem. And then it's going to ask for outliers and the shape. Okay, so let's go ahead and take a look at that. I will move over to mini tabs so we can see what's going on with this data set. Just need to pull up the correct mini tab. All right, so right here, I'm going to use column 6 where it says O age, which is offender's age. Hopefully I put them in right. I did not double check this data set. I did not double check that I typed those in right. So fingers crossed I did that correct. So we're going to do the same thing, stat, basic, display, descriptive. And now I'm just going to move to column 6 instead of column 4. I'm just going to click OK. I don't really need to ask for anything fancy here. All right, so I'm just going to go ahead and write down these things. So I'm going to write down X bar. This one asks for X bar. So that's my mean. So that is 21.84. And I'm going to write down my standard deviation. So that is S. And that is 11.51. And then it asks for the 5 number summary. So it is 12, 15.25, 17.5, 22.75, and 67. Okay. So that's my 5 number summary for this data set. All right, so that completed part A here. That's what it was asking me for. So now it wants to build a box plot. So I'm going to go ahead and take a look at a box plot here on Minitab, and then we'll build it by hand and draw it by hand. So graph box plot, simple again, column 6, and I'm just going to click OK. It will save my preferences that I just used on the last problem. So it will show it horizontally instead of vertically, and it will also have the mean symbol. Wow, this is really skewed right. And I wonder if you guys see why I say that, because look at where my median is. It's right here in the middle. And then look at where the mean is, that far away. Okay, so that definitely is skewed right. So if someone said this is symmetric, that's when I would question, like, well, I don't think that's really right, kind of thing. Okay, so here I'm going to do the same kind of thing where I walk through my IQR. I'm going to walk through calculating my fences and that kind of thing. Okay. So if I'm looking at my IQR here, I'm going to take quartile 3 minus quartile 1. So quartile 3 is 22.75 minus quartile 1, which is 15.25, and we're left with 7.5. Now I'm going to multiply that times 1.5, and I'm going to hang on to that number. So it's 11.25, and I'm going to hang on to that number because I want to plug that in to getting my fences. So I'm going to leave the mini tab here, and we can always come back to it if we need to, but just so we can see this on the big screen. All right, so it really, part B says draw your box plot, but really you need to know where your outliers are located before you can go ahead and draw your box plot. So that's fine. That's part B. I'm going to jump down to part C and complete this first. So it says, are there any outliers, lower fence and upper fence? So let's go ahead and take a look at that. So lower fence, same as before, quartile 1 minus 1.5 times IQR. Now, quartile 1 is this 15.25 minus the 1.5 times IQR. So it was 1.5 times the 7.5. That is my 11.25. Okay. So when I do that, then I'm going to get 4, right? And that's going to be my lower fence. All right. Now let's take a look at that upper fence. Okay, so for my upper fence, I have quartile 3 here, which is the 22.75. And I'm going to subtract the same number, which is that 11.25. And here I will get my upper fence, okay? And that's going to leave me with 11.5. All right, so now I can go ahead and draw my box plot here, and we can see where we're at. All right, so this box plot has a really large span of numbers. If you look at your data set, we start at 12 and we go all the way up to 67. Again, this data set is in order, which is really helpful. But we can also see here, min and max, 12 to 67. So I'm going to count by tens. I'm just going to start at 10 here. And I'm going to count by tens, really, to get up to that 70 here. I'll go up to 80. Okay. All right. So here I'm going to put 15.25. So 15 will be right here, right? So 15.25 is just a little hair above that. And then I have 17.5. So 17.5 would be right in between the 15 and the 20. So that's right here. And then 22.75. So this would be 25. 22.75 would be pretty close to the middle between those two. So there's my box. That one's a lot neater than the previous one. And I'm going to put my X bar 21.8. So this was 22, 21.8 is like right here. And this is exactly what we visualized on Minitab, right? We definitely looked at that on Minitab. Now let's go ahead and put our fences on there. So 4 is just off the charts down here. I don't really have to worry about it, but I'll just put it on the edge. And then I totally subtracted in my upper fence. I'm just realizing this now. I subtracted instead of adding. I even wrote subtraction. I apologize for that. So I have my 22.75 plus my 11.25. Goodness, 34. Okay. You guys are all probably screaming that that is totally wrong. There we go. And there's my 34. Sorry about that. Okay. So any value above 34 in my data set is going to be an outlier. So we can take a look at this data set. There's a whole bunch of outliers. We already saw that in Minitab, right? But I have one at 67. So I'm just going to take this so I can go down along these numbers and start putting in asterisks, okay? So I have at 67, I have an outlier. 59, I have an outlier. 54, I have an outlier. 50, 46, 43, 36, and then 34. And this is at 34, this value. Okay. So what I'm going to do is I'm going to draw my whisker to 34. And so my whisker will actually go to the fence. I rarely have that happen. Okay. But it's going to go right to my fence here. Now on my lower side, it's going to go my minimum because my minimum is 12 and my lower fence was 4. So I'm just going to go to 12 here, right around here, and that's where my whisker will go. Okay. So I hope you guys can see that that's clearly a skewed right. So in part D, when it says, what shape do we have? I'm hoping you're all saying skewed right. And you can say because X bar is greater than the median, which is the same thing as quartile 2. All right, and we can see that. All right. All right, let's move on to question number 8. So question number 8 here. All right. So here we're looking at the shelf life of packaged foods. So we're looking at dry cereal and we're looking at the moisture content. So it says that we're looking at the time on the shelf, which is X, which is the number of days, and the moisture content, which is going to be Y, and that's in percent. Okay. So what this actually is, this is going to be a linear regression problem. So we want to know, is there a linear relationship between X and Y here? So the days on the shelf and the moisture content. And we are also going to go ahead and build that model and interpret some values. So this is for number 8 on the review sheet. So again, I went ahead and I typed in all these numbers into Minitab. Remember, you want to make sure you label them X and Y. So you know which one's X and Y. It's labeled here, and I also labeled it on my Minitab. But the big thing here is that this X, so 0, goes with this Y of 2.8. I know it's hard to see here, but this X of 3 goes with the Y of 3. So these are pairs. So you have to make sure you put them in the same column. So I'm going to go ahead and share that screen. Same Minitab file. So we can see over here columns 8 and 9. We have X and Y, okay? And those are pairs. So you don't want to mix those up. All right. So it says, which of the following is the definition of the correlation value? So what does correlation value mean to us is what this is saying. Correlation value measures the strength and direction of a linear relationship, okay? So anytime you have like a little multiple choice question, doesn't matter if it's on part 1 or if it's within part 2, and it's something like that, think about what it means and then look for your answer. That's my suggestion to you. So here it says measure of the cause and effect, strength of the relationship between 2 variables, strength and direction of the linear relationship of 2 variables, measure of the indirect relationship. So it's answer C. So A is answer C, where it's the strength and direction of the linear relationship between 2 numerical variables. So now that we know that, now we want to go down to part B and we want to actually find R, which is our correlation value. Now, the correlation value is the one that we easily kind of forget where to go because it's not under regression. This one's under basic. So stat, basic, and now we'll go to correlation, which is down towards the bottom. So when I click here, I'm going to put my X and Y. The order doesn't matter, although I try to be consistent with putting X in first and Y in second. Now, the reason why I do that is because we will get a scatter plot here. If you put X in first, that will be your horizontal axis, which is your X, and then your Y would be your vertical. So if you swapped those, then it would put Y as a horizontal, and that would be backwards. So for the calculation of the value R, it doesn't matter, but if you look at that graph at all, it does matter. So I just get in the habit of putting X in first and then Y in second. So here we are. Here's our scatter plot. It's really linear. Look at that, except for this little guy down here, and then this one up here is off a little bit, but this is really linear. And I'm going to look for my R value. Now you can go a couple places. You have it here, 0.953. Or down here in the bottom, 0.953. So that is my R. And that is a really strong linear relationship between X and Y. So it says here, find the value of R. A lot of times we have to interpret it. So I'm going to go ahead and interpret it, even though it didn't ask. So I'm just going to stop this so you can see. I know you can see this in the upper corner, but we'll look a little bit more. So how would I interpret this value? Okay. So I would say something like there is a strong positive linear relation between those 2 variables. Now I'm always going to put this in context, right? I don't want to see X and Y. So you could put between, you could put time on shelf, you put days, whatever you want to put. Okay. And moisture content. Let's see. I'm just going to put of dry cereal. All right, there we go. And that's how I would interpret that value. Okay. Let's move on to part C. Part C wants us to get the equation. So I'm going to go back to my Minitab and take a look here. And So when I look at this here, I'm going to, there we go. We're going to go to stat, regression. We're going to build our model. So regression again, and then fit my regression model. So here, I already have this in because I just did this in today's review class, but so here I have my response, that is Y, that will be moisture, and continuous predictors, that is X, that's the days on the shelf. I don't have to do anything fancy here, so I could just go ahead and click OK and just move forward. Now, I want you to know when you're looking at regression, the output, there's a lot to it, and I don't want you to get overwhelmed, but the very first part is the regression equation. And that's what we're asked for in part C. So my regression equation, you can write a couple of different ways. I'm just going to write it with Y hat, but you could put moisture if you wanted, like how Minitab gives you. I'm just going to say Y hat is equal to, now I want you to notice here in the equation, it says 2.7855 plus 0.04462 shelf. And what I want you to recognize is this is just Y equals MX plus B, but they swapped the order of MX and B. So it's Y equals B plus MX, right? M is my slope of my line, and that is right in front of X always. So I just want you to recognize it. Just swap the order. When you write it, it doesn't matter which order you write it. Anyone reading it should know if someone needs this. I'm just going to swap that order back because I feel like we're just so used to seeing it that way. But that is completely unnecessary to do that. Okay, there it is. So here's my equation. Now in part D, it wants me to interpret the slope. So that is this number, the 0.044 number. Then it also wants me in part D, part E, it wants me to recognize what R squared is and interpret that. So let's go ahead and get that since we're right here. R squared is just down here in model summary. R squared is right there, 90.75. So I'm just going to write that here. Now remember, for the least squares regression line, R squared is actually the same thing as lowercase r being squared. So I could take my correlation value and square it to get this number, or vice versa, you could take the square root of 90.75 to get my R. So if we forget, like maybe where R squared is located in the output, you can get it if you already have your R. You could just square it. Or if you forget where to find the correlation value in Minitab because it's not under regression, it's okay, just take the square root of this, right? So there's a way to still find it, okay, if you can't remember where to find it in Minitab. Okay, so on part D, it wants us to interpret the slope here. So I just want you to remember the slope is always interpreted for each unit increase in X. My Y will be affected by that slope. So we have to think about what X represents. It's the time on the shelf. So time is in days in this one. So I would say for each day increase in time on shelf, the moisture content will increase. Now I'm saying increase because it's a positive value. And I'm going to increase by that value. And it's a percentage. And I always add on average. There. Okay. So that's the interpretation of my slope. It's always for each unit increase in X, what's happening to my Y. Now for part E here, R squared we already identified from the Minitab that it's 90.75, which is great. But now I want to interpret what that is. So remember, this is the percent of, or the proportion, either one, of variation or spread of my Y values that's explained by my regression line. So I'm just going to write that out. So I'm just going to say 90.75% of the spread, or you could say variation, And now the Y was moisture content. And be explained by the line. You can write the equation out. You can write by the regression equation. You can write it different ways, but the line, that's what it is. Okay. Now part F is asking us, is the line a good fit? Now, if you remember when we were studying chapter 4 correlation, if my R squared was closer to 1 or closer to 100%, then that meant it was a really good fit, right? So closer to 0 is a poor fit, closer to 1 is a really good fit. So 90.75, that's closer to 100% or 1. So yeah, this is a good fit. So I will just say close to, and what the blank was looking for is 1 there. And that's because R squared is between 0 and 1, okay? And closer to 1 is better fit. All right, and that's question 8. All right, let's take a look at question 9. This is the second hypothesis test on the review sheet. Remember, hypothesis testing is a big part of the exam, since this is the last topic we learned and we have not had it on an exam yet. So question number 9, a social worker claims that among all elementary school children, the mean time spent playing video games each day is more than 2 hours. So that is key for us, more than 2 hours. To determine if she's correct, we took a sample of 31. So I'm going to start writing this down. So my sample is 31. So N is 31 kids, and found that the sample average, that's my X bar, is equal to 2.5. And my sample standard deviation, which is S, is just 0.5 hours. Okay, so we have this information, and now we can move forward and we can actually write up this full hypothesis test and see what's going on. So remember here, we're always going to start with the population step, and in here, we're going to identify the objects. So the objects are who we're studying or who we're giving the survey to. So here, I'm going to say, okay, well, this is the elementary school children. Now, my variable is what I'm studying about these individuals. Now, the variable is the amount of time spent playing video games. Okay, so I'm just going to say time spent playing video games. And then I have my unknown. Now my unknown, remember, is where I'm going to put these two together, but I have to identify what type of variable I have. So if it's time, I'm hoping you recognize this as numerical. Okay, so for my numerical problem, then that means my unknown is mu, and I want to define mu. So I always start the same way. Mu is the population mean. And now I'm going to put these two together. Typically, when I'm looking at numerical, I start with variable and then end with objects. And then a lot of times with categorical, it's flipped. Okay. So what I mean is I'm going to write my variable first and then my objects. So mu is the population mean time spent playing video games. By elementary school children. All right, so now I'm going to move on to my goal. So if you remember what I said in the beginning, a social worker thinks that the mean time is more than 2 hours. That's my goal. But let me write it down in my method step first, and I'm gonna come back to this in just a second. So I have my method step. So here we want to identify the null, alternative, alpha, and what curve I'm on. So my alternative here is going to be mu. Now she thinks it's more than 2 hours is greater than 2. Okay. Then my null is mu is equal to 2. Alpha was given to me in the problem. It says use a level of significance 5%. So 0.05. And since this is numerical, I'm on the T curve. And remember, the T curve changes shape based on degrees of freedom. So I just want you to write df equals n minus 1. You can put what n minus 1 is. Like you could say it's 30, but you don't need to at this point. All right, so my method step is complete, which is pretty quick, but I need to take my HA. This is it in symbols, and now I'm going to take this and write it in words up here for my goal. So my goal is to say that the population mean time spent playing video games. Video games by elementary school children is more than 2 hours. Okay. Full context. All right. So now once I'm done with that part, I can move on to my sample, which is basically what I did up here on the very top when I identified n, x bar, and s. I'm just going to write those again. So my sample step is really done. So n was 31, x bar is 2.5, and s is 0.5, and then I'm going to check for normality. So remember, I have a couple different ways here. I'm always going to use n is greater than or equal to 30 if I can, and it is, right? It's 31. So I'm just going to say yes, normal. Now, say that did not take place. So say n was like 20. Even if it was 29, it was just less than 30. It doesn't mean it's not normal, it just means I can't use the central limit theorem to say that it's normal, right? So in that case, I would look to see if I have raw data. And if I did, that's when I would draw my NPP to see if it's linear, okay? So that's what you would do in that scenario. But for here, this one's perfect. All right, so now I'm gonna move on to that results step. So under results, remember I'm going to get my t-test statistic. I'm going to get, I'm going to interpret the value, I'm going to get the p value, and I'm going to interpret that value here, okay? So for here, I'm going to go over to Minitab again. So I'm going to go ahead and open up that Minitab screen one more time. Now, I don't have to have any data in here. I'm just going to plug it into the feature. So remember, you use the same features for test and hypothesis, for hypothesis tests and CIs. So here it's stat, basic, one sample T. All right. So that's for my numerical. Now, if it was categorical, you would choose one proportion. Okay. And it's the same feature. So if I was doing a CI, I would go to one sample T as well for numerical. All right, so in here, I'm just going to plug in all my data. I had a problem already in here from earlier today. So I have 31. My sample mean is 2.5. And my standard deviation is just 0.5. I'm going to perform a hypothesis test. It wants to know what my center is. What does my hypothesize mean? That is my null. That was just 2. Of course, I'm going to choose options. Now, remember my confidence level, I don't need to change. That is just for a CI. But I do need to take a look at my alternative, and I need this to match my HA. So here, in this case, my HA is a greater than, so I'm going to match that. All right, I can click OK twice and get my output, which I'm looking at right down here. Okay, so here's my T and my P. Remember, P is not 0, it's very small. So T, I'm just going to write is 5.57. and p-value very small. All right, so let's go ahead and write out these interpretations and come up with our conclusion. So I'm just going to say my X bar is 5.57 standard errors above, because it's positive, so it's above my center, which is 2. Okay, my p-value, it's very small, so now I'm going to write my interpretation of my p-value. So if the population mean is 2, there is a very small probability of getting a sample mean at least as extreme as the one we got from sampling. There it is. That's my interpretation. Okay, what the p-value represents. The probability of it happening again, right? Okay. Now that we're done with that, we can move on to the conclusion, right? This is what we're trying to get to. After that long step, my conclusion, I always answer or ask myself the same question. So is the p-value less than or equal to my alpha, right? So it's very small, less than or equal to 0.05, then the answer is yes. I can reject my null hypothesis. Okay, now I'm going to go ahead and write my conclusion. So at the 5% level of significance, we can conclude that, and I'm going to write my goal again. The population mean time spent playing video games what did I use for my wording? By elementary school children? Okay. Is more than 2 hours. There it is. Okay, that felt long. That conclusion. All right, so I'm rejecting my null that it's 2 hours. I'm saying yes, it is more than 2 hours. Okay, so hopefully that is helpful. All right, guys, that's the end of the review sheet. I hope that's all helpful for you guys. There's also the first video that is out there for questions 1 through 5. Thanks so much.